Okay, we are back. I say that at the beginning of every video. I'm so sorry. I just like to assume you may not be watching these in order, or you may not be watching all of them. I don't know. Anyways, it's late. Okay. May 2025, IB Chemistry, TZ2, Paper 1A, HL. We're doing it. Questions number 31 through 35. Two more videos left. Two more. Okay. This is just as painful for you as it is for me. Okay. I have like an hour long over an hour of footage of me yapping. Okay, anyways, number 31. This is what is required to convert a base into its conjugate acid. This is literally just asking about the definition of a conjugate acid conjugate base pairs. What differs a proton? That's it. To proton D. Crazy. Okay. And when you look at the other options, some of them are designed to trip you up. Okay. So I'm just gonna use random example. Like what's a good example off the top of my head? We're gonna say NO3 minus 2. No, that's a bad one. What's a good base? A base NH3 to NH4 plus. Let's use that one. Just as for funsies, okay? So a negative charge. Well, neither of these have a negative charge, so it's not that. A hydrogen atom. Bad. You may think it's a hydrogen atom, but in H, lone pair. And then you have H. But it's not H because this is an acid base reaction. Is essentially, your little arrows for organic chemistry, nucleophile to electrophile. This is just that. That's why we have Lewis acid base theory. Okay, it is H plus because it is electrophilic. Okay, but then you have this nucleophilic NH3. Okay, and so that reaches out for that. So it's not just an H; it's an H plus because in order to make that new nitrogen to hydrogen bond, it has to be an electrophilic. It has to reach out to that like electrophile. Okay, cool. Also for an electron pair, this would be if it was going from the conjugate acid to the base. That might be right. Because if we were going from NH4 to NH3, that would now on the product side have that lone pair. But in this case, we're not actually adding a lone pair, as we are essentially getting rid of a lone pair. So that doesn't really make sense. And then a proton, that's what makes it. That's what that H plus is. So yeah, yeah. Also feel like this could be vocabulary. But yeah, that one is D for number 31. Okay, question number 32. This one is which solution has a pH of 9? And so normally, like it'd be like there'd be some acid options to the distractor, because obviously a pH above 7 is going to be something that is basic. Okay, and so our options of NH3 and NaOH in various concentrations are all bases, so that doesn't help us very much. However, NaOH is a strong base, so we can tell directly what the concentration is uh, to pH, okay, without any other calculations because it completely dissociates. Meanwhile, with what is it, A and C have NH3. That's ammonia, or that's from ammonia. Ammonia's a weak base, or a classic weak base, okay? And so with our weak base calculations, we need to have the pKb equation. We need to have the concentration of something, but we also need the Kb. Since we don't have the KB, especially since in the old data booklet, we did have some of them, but now we don't in this data booklet. So that can't be solved with just the concentration alone. We have no idea. So those ones are crossed out immediately because of that. Because there's no way it's possible. Okay. Um, and so for B and D, you can calculate the POH first and then subtract it from 14 because POH plus pH is going to be equal to 14. So you can use that to solve for one or the other. Okay. So in this case, for B, our POH is going to be equal to 9. So it's just negative log 10 to negative 9. And so that's just going to be equal to the exponent. Okay. Meanwhile, 14 minus 9, I can't do math in my head, but that's 5, right? I have to check myself. 14 minus 9. Oh, thank God it is 5. That'd be really embarrassing if I did that wrong on camera. Anyways, so that one's not right. Meanwhile, with D, we have this 10 to the negative fifth. So our POH is going to be equal to 5, and therefore 14 minus 5 is now 9. So that makes D the correct answer for number 32. Okay, question number 33 is asking about what is the main reason why sulfuric acid has a lower pH than methanoic acid of the same concentration. Okay, and so sulfuric acid, we should recognize immediately that bad boy is a strong acid. If you're wondering, how do I distinguish strong and weak acids? Because we only know 5 strong acids. If it's not one of those, it's weak. Okay, and those are directly listed in the subject guide: sulfuric acid, nitric acid, HCl, HBr, HI. HF is not one of them because that HF bond giga strong. Anyways, so those are the big five strong acids. In addition, it should be known that methanoic acid, meth is one of our organic prefixes. Okay, so that's saying that is that like CH3COOH. No, it'd be C. Yeah, CHOOH. There we go. Methanoic acid. My bad. Got that wrong. Anyways, unrelated. So that is our organic acid. All organic acids are weak acids as well. Anyways, so but yeah, weak. Okay, so this is actually just asking is why strong acid low pH, why weak acid higher pH? Ooh, boogie boogie. Okay, so our options are A. Sulfuric acid is diprotic, whereas methanoic acid is monoprotic. That's not right. Because yes, sulfuric acid is diprotic, but that's not the reason. Like that's once again true, but not the reason why. Okay, so the big thing here is the main reason. Okay, and so that is not the reason why. Is if you had a strong and a weak acid that were both diprotic or monoprotic, it would still be the same thing. The reason that wouldn't change anything about the difference in the pH. Okay. Meanwhile, B. Wait. Also, hold up. Also, if you had something that was the same concentration, okay, and we're pretending that the strong weak acid thing, we're forgetting that that exists for a second, okay? If you have something that's the same concentration, sulfuric acid being diprotic means that it would take twice as much concentration to reach a lower pH. So actually, that reasoning doesn't even make sense. Anyways, so B is sulfuric acid ionizes more than methanoic acid. Yippee, that's just the definition of a strong acid. So yes, that one is true. And so we're gonna put a little check mark there, as we think that one's right. But we're gonna look at C and D. Always look at the other answers before confirming. So C, sulfuric acid has a stronger conjugate base than methanoic acid. So that one also doesn't make sense because a strong acid has a weaker base. The stronger the acid, the weaker its conjugate base. So that would technically, sulfuric acid should have a weaker conjugate base. And that would essentially be implying that sulfuric acid is a stronger acid. So it's wrong. So C is wrong. D, sulfuric acid is more soluble in water than methanoic acid. Dog, what? Hello? That doesn't make sense. Like that doesn't how does that affect the pH? In fact, once again, that would technically be listen, like if you have something that's more soluble in water, give me a second. I'm reasoning this out here. Is if you have something that is more soluble in water, why do we need to be dissolving it in water in the first place to take its pH? We don't. We can take the pH of pure sulfuric acid. It would hurt our eyeballs, but we could do that in pure methanoic acid. And it's the same concentration. That don't make sense. Okay, D wrong. So B is the right answer. Sorry, ignore my little breakdown there. Okay, so number 34 is about which salt is basic. This is about the hydrolysis of salts. Okay, so I'm going to first explain the theory, and I'm going to tell you my awesome metaphor that helps me remember this all the time. Is it a little out of pocket? Yes, but all of my metaphors are. Okay, and that's what makes them rememberable. Okay, so for A, we have the salt that has, you need to identify the anion and the cation. Okay, so your anion is H, COO minus, your cation is Na plus. So you're going to see if either of them would react with water. Okay, so if you react your anion with water, you would get HCOOH plus OH minus. This is a weak acid. Okay, and this reaction is an equilibrium. Weak acids can exist in an equilibrium, so this will occur. Okay, Na plus, if it reacts with water, is it forms NaOH plus H plus. Okay, and so if it were to undergo this type of reaction, but NaOH is a strong base. Therefore, it cannot exist in equilibrium, and this reaction will not occur. Okay, so only the first reaction occurs, and so we have an excess of OH minus. So the pH, it's basic, and it would be above 7, okay, of that salt. Okay, so A is right, but we're going to look at the other ones because, once again, concepts. Okay, so for B, we have HCOO minus. Once again, we already established, I'm just going to put a little arrow there because we already established as above that we would produce excess OH minus. Okay, now let's look at the cation. So here it would be NH4 plus. Okay, so if you react that with water, is you would get NH4 OH, which is just NH3. That is a thing. Plus H plus. And since that is a weak base, that will happen. Okay. And so you're going to have excess H plus and excess OH minus. Those two essentially cancel each other out, and this just stays neutral. Okay. So the pH is still 7. So that one's not right. C, Na, NaO3. We already established Na plus, no, can't react. Okay. As seen in A. Meanwhile, with NO3, it would be NO3 minus. If that reacted with water, is we would have this HNO3, okay, plus OH minus. And so HNO3 is nitric acid. And so that is a strong acid. Therefore, this reaction will not occur. So that's still, once again, going to stay neutral there. Meanwhile, D, we've got NH4Cl. We already established NH4 plus would result in this excess H plus. Cl minus is similar to Na, where that would react with water and form this HCl plus OH minus. HCl cannot, it's a strong acid. I'm just going to put SA, and we're going to ignore the underlining meaning of that, but okay, nope, I'm going to write it out. Strong acid. There we go. And so this reaction cannot occur. So you have excess H plus. So this would be acidic and below 7, the pH. Okay. And so that would be all of these. So A is still the right answer, but I still want to go over all of them because this is a concept that students struggle with. Now, for my metaphor. Okay, listen, hear me out. Hear me out. I say this all the time. Hear me out. But so you have, because it's all about strong acid, weak base in terms of your parent acid and parent base, right? Okay. And so if you have strong acid, you're at a party. You're turning it up. Okay. There's strong acid. There's a lot of drugs at this party. That's not good. That's bad. And you have weak base. The music's terrible. The vibes are bad. So your pH is less than 7. The salt would be acidic. If you're at a party and you have strong base, the music is pumping. Okay? Weak acid. Nobody's doing drugs. Maybe there's one kid in the corner, but we don't worry about him. Okay? The vibes are good. The vibes are excellent. The pH is above 7. The salt is basic. And that's how I remember the hydrolysis of salts. I'm not kidding. This is how I remember it. I forget the theory sometimes because it's been so long since I hashed it out because I just remember the metaphor so well. Okay, and so this 35, this one is what is the best indicator to use with the titration of phenylamine with nitric acid. Okay, this one is literally just the hydrolysis of salts in a different shape. Okay, so with like your pH curves, right? Okay, the big thing is you want your pKa to be where your equivalent point is going to be. Okay, is where that pH is going to be at your equivalent point. Okay, which you can know from the pH of the salt, which is just the hydrolysis of salts. Crazy, crazy, right? And so I'm not going to explain that theory again. So we're going to go with the metaphor. Is all we have to do is identify whether phenylamine, strong acid, weak base, whatever, as well as nitric acid. Nitric acid, we already said before, is a strong acid, very strong, unlike me. And phenylamine is obviously going to be a base because that's our only option. However, lots of students miss this connection between organic and acids and bases. Amines. Amines are like ammonia's cousin. Okay, it's like your NH2s. Okay, like y'all don't have to know what phenylamine looks like. Spoiler is it is just a phenyl group with an NH2. But anyways, y'all don't have to know that. All you have to do is the amine. That's your basic group. That's your weak base. They are all weak bases. All your amines are weak bases. They're ammonia's cousins. Okay, so weak base. So you have weak base, you have strong acid. Lots of people on drugs, terrible music, the vibes, bad. pH below 7. So you're looking for the thing on these options that has a pH below 7, which is A. And that's literally it. Okay. B, C, and D. B is exactly 7, but that's not right. So yeah, A for 35.